Uh, okay, hello all. Welcome to Data Science with Julia. So, like in this playlist, we have seen about algorithms like genetic algorithms, and we have guessed a number with it, and we have fit a curve to us or a line to a set of points with it, and all those stuff. Now, what we are going to do is like we are going to look at a classification algorithm called K nearest neighbor. So it is, I think, one of the easiest. I think it's easiest because I know about it. So that's the thing, in and out. So that's the thing. As we progress and as we discover, like everything will become easy. So not a problem. If you don't know something, yeah, it will first be difficult. So that's the thing. Let's take a look at this algorithm, what it can do, and I will first explain the theory. And if time permits, then I'll just go into the code of it, and we will try to classify oranges depending on the k nearest neighbors. Of course, we are not doing dealing with real data. The point of this video is to deal with to what to say test our understanding. So that's the point of this video. Okay, so that's the thing. Okay. Possibly, in the future in this playlist, we will deal with real stuff and we will use algorithms. We will clean data and we will just do, okay, a real situation stuff and all those things. So, okay, yeah. Anyway, let's go into it. So, the first thing is you just have a bunch of points. So let's say, okay, yeah, we have red points at the top right and blue dots. Okay, I'll call them as dots. Like point is like almost no dimension, right? So theoretically, point is no dimension, but yeah, if you put it physically, it's almost no dimension. Yeah. So yeah, you have a set of blue dots and you have a set of red dots, right? And let's say like you have a place over here and you mark it as X and you say like I'll just if there is a dot over there, what it will be like, will it be red or blue or whatever it is. Intuitively as a human you know that could most probably be a red dot because you know it's nearer to the red stuff. Okay, so that's the thing, because you are a human, you have a lot of data in your brain and all those stuff, and so because of that you know, okay, this is red. But how to tell a computer? Okay, so like okay like okay so computer, what you can tell it to do is like you can tell it to find the distance between x and each and every dot. So distance between x and this red dot, next red dot, next red dot, next red dot, and so on and so forth. Then it comes to blue dots. Distance between x and this blue dot, blue dot, blue dot, and I think this is the farthest, and this is the nearest red dot. Okay, so this blue dot is the farthest dot, and this red dot is the nearest dot. Okay, so you will just find a distance, and what you will do is depending on it, you will order it out. So this red dot is over here, and this farthest blue dot is over here, and I think the next red dot will be this one, and all those stuff. So you just order it. Okay, so you just order depending on the ascending order of the distance. So that's it. The idea is if something is far away, you say okay, if something is near, then most probably the x belongs to the nearest thing. So that's the thing. So that's what this nearest neighbor means. Okay, we'll see what is k. Okay, okay, so you have found the distance and you have ordered all these dots and all those stuff. Okay, now choose some value, like, okay, this will come with educated guess or something like that. Since we have 6 and 6 over here, so I've chosen k is equal to 8 or something like that, right? Okay, so maybe even 5 should work or something like that. Okay, so I've chosen k is equal to 8. So now you select the first 8 dots over here, right? So the first 8 dots you just select. Out of this, 6 is red and 2 is blue. So the six most nearest neighbors to this x are red and 2 are blue. Okay, so which means 6 is the winner because the most number of counts, right? So it's kind of voting and all those stuff. So that's the thing. Yeah, if you go to my blog, you can download this diagram over here, and that's how it is. And I just use a program called Draw.io. Draw.io. Okay, come on. Yeah, this one. There is also a version where you can download and use it on your computer and all those stuff. So that's how it is. So this is the program I just used. So you can even download it and use it in your local, right? So that's how it is. So yeah, this is how k nearest neighbors work. So you just find the nearest neighbors and you just select like k, like it's some number, okay, and see which one of the neighbors are the highest one, and then you just say that this unknown belongs to that neighbor. Okay, so that's it. So now let's go to action, like see how things are done and all that stuff. So let me just create a notebook, rename it as KNN. Okay, KNN, and yeah, fine. So, okay, so let's assume, okay, I need to tell the scenario over here, right? So, let's assume like you are in some orange factory and you're just, they have just told like, okay, they want, okay, like now employees just look at oranges and put them in different bins, okay? So in the future system, they want something, a robotic system to measure the size of an orange, possibly using cameras or something like that. And then once it has measured, it needs to automatically put into the bins. But the thing is, like, they are not sure what size of orange goes to what bins. Like, employees have been doing, and the customer is okay. So what you start doing is like you start measuring the size of oranges in each and every bin, and you just make a table and you give it to k nearest neighbor to predict the, okay, if you give the size of orange it will just predict. Okay, so let's say like this company is selling oranges to three types of sellers. Like one sellers are like luxury hotels, others is for edible fruit like retailers and all those stuff, and other is for juice companies. Okay, so it happens that okay, any orange that is greater than 6 inches in size, okay, it goes to luxury hotels because they would like to have a big display and all those stuff, right? So that's the thing. And any orange that's whose size is greater than 4 inches uh, goes as edible fruit, like so that like people can peel it and eat it and all those stuff. And anything less than that only goes as juice. Like it doesn't matter what size of orange goes as juice. One side you will get as pulp, and another side you will just get juice, right? So that's the thing, right? So we are not in a real situation. So I've just written a function called category, which when given orange size will just give this category. Okay, so our goal is to predict this category. Okay, so we are just testing it. Okay, so category of 1.5 is like, I think it should be juice. Okay, right? And yeah, it's actually better to test whatever you just write, you just test. There is also another software development methodology called test driven development, and that's how things should be done. But yeah, like, okay, so if you give 4.5, it goes as edible fruit, right? Okay, and if you give 6.2, it'll go as luxury hotels. That orange should be sold to luxury hotels. Okay. So, okay, now let's generate fake data. This thing I'll just try to explain. Okay, so you have a function over here, and okay, like, okay, yeah, let's try it and see. But yeah, of course, the point of this thing is not like, it's not to explain about like data generation and all those stuff. The point is about k nearest neighbors. Okay, so yeah, let me give me the luxury of rushing a bit. Okay, so what we are just doing is like, let's say like we are just tabulating the orange sizes. 3.5 inches means juice, 6.9 inches means luxury hotel, 7.5 luxury. So we are just assume that you are in a factory and just taking the orange sizes in bins, and then you're just what to say, noting like, okay, if I get a orange size of 3.4 and I find it in juice bin, yeah, I just put the data like this. So it is nothing but, okay, the size and the category. The category function only you wrote, right? Like, so this is the category function. So this goes as a tuple, and we are just taking it as array of tuples, and we have 50 readings and all this stuff. Since it's all like kind of random stuff, you might get something a little bit different and all those stuff. But overall, it's going to be the same, right? So that's the thing. Okay, now you saw, okay, like let me even open this thing, like mm, this k nearest neighbor, because we need it, okay. So we saw like we are finally counting over here, right? So for that we have a function called count. Like to do that counting, we have a function called counter, right? So in it, let me explain how it works. So okay, let me explain it with the example so that like it will. Okay, so yeah, so I'll just have this thing like, okay, counter and all this stuff, okay. So what it does is, okay, look, in this array of elements, like you have this juice twice, okay, so it's put 2 over here. So it returns a dictionary, that is like the key is juice and the value, the number of counts is 2. Edible fruits is only 1, okay, you can only find one edible fruit. And then luxury hotels is only 1, so you can only find one in that. So that's the thing, right? So this is how it works. So you have a dictionary, okay, an empty dictionary, right? And for each and every element, what you do is like counter of elements. So if the first thing is juice, it'll go as counter of juice, okay. So over here, this one is something that's get is some function that operates on dictionary. What it does is it takes count, okay. So count of dictionary has no value, so it returns a default value of 0. So first time it returns a default value of 0, and then we increment it by 1. So now it becomes 1, okay. So count of juice becomes 1. So similarly, once again it just goes over here, and finally when it comes over here, now count of 0. Now it will be like get counts of juice. So now it should be 1, because we already have it. It should return 1. It won't return this default value 0, okay. So now 1 plus 1 will become 2. So count of juice will become 2. So that's how it is. So that's how it happens for each and every element. So it will become juice, edible fruit, juice, luxury hotels, and all those stuff. This dictionary gets built up. So yeah, if you're not familiar, yeah, please read about dictionaries in Julia. Okay, so that's the thing, right? Okay, so we have this uh, uh, counter. Now we need a function to get the highest thing. So out of these two, look, you can't tell what to say, end user of this machine learning algorithm, like, look, this could be a red dot or a blue dot, or this could be a edible fruit, or what to say, a fruit that could go to a luxury hotel. You can't say like that. Okay, maybe you can say it with probability, but I don't think you can give multiple options. People want some concrete solution. So it's for that only we counted like, okay, 6 and 2. So this should be 6. So this X should be a red dot. So that's the highest thing. So yeah, we need to get the highest vote. Okay, so for that I've written a function over here. Let me explain it to you. Okay, so how it works and all those stuff. Maybe yeah, if I okay, so right, let me just okay, yeah. So you already have counts like this. So I just put highest vote of counts. Okay, right. Okay, so you okay counts variable you already have. If you want, yeah, I just do it once again, right? So now we are just putting highest vote of counts. Okay, so it's juice. Okay, so juice is 2 and all those stuff. So it works like this. Okay, so initially the maximum value will be 0. Okay, so and the maximum vote will be, I'm just putting it as an empty string. So I think it's better to use a thing called nothing that's there in Julia rather than this one. But yeah, this should work for now. Okay. Actually, yeah, possibly this playlist might look into coding perfection and all soon. But yeah, now it's our objective is mostly to learn data science with Julia. So that's the thing. So now you unwrap this dictionary as key value. So this is key, this is value, and all those stuff. So first it will be like, okay, edible fruit. Okay, so the key will be edible fruit and value will be one. And if the value is greater than Maxwell, of course, one is greater than zero. So Maxwell is zero. So Maxwell will become value. So Maxwell will become uh, 1. Okay, so that's the thing. And max vote will become key. So it will become edible fruit. Okay, so now the second thing will go juice and 2. Okay, so similarly, yeah, like the value 2 is greater than Maxwell, which is 1 now, right? So the Maxwell will become 2 and the max vote will become juice. So that's how it is. And luxury hotels and 1 will go. So the key will become luxury hotels and the value will be 1. Value is greater than Maxwell. Maxwell has already become 2. Okay, so I don't think so. So 1 is not greater than 2. So this will just skip. So max vote will contain the key that has the highest count, and that gets returned over here. So and you just get juice over here. So that's the thing, right? So that's how it works, right? So yeah. Now let's plot our sample value. So what I'm just doing over here is, right? I'm just having this thing called key values, and it's not a very good name to put for a dictionary, key values and all that stuff. Okay. And what I'm just taking this orange sizes. Orange sizes, you remember, right? We generated over here. So some random sizes, right? And what I'm just doing is like okay, I'm just having a dictionary and I'm just having a key called edible fruit, and all edible fruit sizes will go over here. So just go over here. Similarly, all juice sizes will go over here, and similarly, all luxury hotel sizes will go over. So this is nothing but a dictionary of arrays. So that's how it is. And so this is what we are just doing. Like, okay, orange sizes we are having, and size and cell. Cell is nothing but I'm just calling this one. You need to sell it as edible fruit, or you need to sell it as juice, or you need to sell it as luxury hotels or something. So we have this key values of cell. We are just putting it as size. We are just putting, okay, key values of cell. We are just pushing this size. So for if the, okay, so let me just put like orange sizes over here. Sizes, okay. So, okay, the first thing we'll just have it like size, okay, 3.5, okay, and it'll be juice. So, so the key value of juice will be 3.5. Okay, so yeah, so it is 3.5. Similarly, let us come to juice once again. Okay, so it'll just iterate. Once again, the key will be juice. Okay, so and that will have an array of 3.5, and now 2.3 will get pushed into it. So that's how it is. So okay, so 2.3 gets pushed. Okay. Similarly for others too. So I'm just talking about juice so that like I can tell you what happens. So each key, okay, value of each key is being treated as an array over here. So that's how this one works. So okay, why I'm doing this is to plot it. Okay, so that's what we are doing over here. Right. So right. So before doing any data science, look, we still haven't gone into this k nearest neighbor. Okay, so all we are just doing is data generation. We are doing. We have put some things that are needed for k nearest neighbor, and we are just plotting it. Okay? I don't want to go into this plot much. Okay, so but I'll just say what it is. Okay, so we are doing a scatter plot, and we are plotting edible juice with label juice. Okay, so and we are putting the color blue, right? And what we are just doing is like we are taking key values of this label, that is key values of juice. Okay, so all these stuff we are taking, so all these stuff we are just taking, we are plotting it as blue. Okay, so these are all goes as juice, and similarly it's for edible fruit that's been plotted over here in red, and finally what goes to luxury hotels has been plotted over here in orange. So that's how it is, right? So that's the thing. I think we can even put orange as small o and all those stuff. It should still work. So that's how it is, right? So Okay, yeah. So something happens over here. If you run the plot again and again, like what to say, like it puts this double thing, like juice, and all those stuff. So don't do it. So yeah. So I just want to explain that. Okay, you can even put orange with lowercase o and all those stuff. So that's the thing, right? Okay, now for k nearest neighbors, we need to find distance, right? So this distance we need to find out. So no need to find like okay, like something like a distance in a plane and all. This is just a normal line. So let's say like you just have a size over here, that is over here, right? So we need to find distance between that and every other point in this vertical line. So what we are just doing is we are doing absolute distance. So that like distance will always be positive. It doesn't mean that like if you walk 5 kilometers east, it's 5 kilometers, and if you walk 5 kilometers west from your home, it'll become minus 5 kilometers. Okay, no. If you walk 5 kilometers up and down, you've totally walked 10 kilometers. Okay, so that's the thing. So it should always be absolute distance. Okay, so we are keeping it as del. So remember, we also kept this as error and other stuff. Okay, so and yeah, I don't want to try this. It's very easy thing. Del of 3 comma 10 and all that stuff. So what we plan to do is like we plan to get this error, that is the distance label. Okay, for each and every orange size, right? So for each and every orange size, okay, we want to get some kind of okay, let's say like we have orange size of 5. So the distance is 1.5 comma juice. Okay. And over here is 5 minus 6.9 absolute is like 1.9 comma luxury hotels. Okay. So that's how we just want to get a array of tuples. So that's how we just want to get like that. Okay. So yeah, so the error or the distance we want to get and label, and second error, second label, and all those stuff, and we finally want to sort it. So that's how we want to do. So the label we are calling it as cells over here. So where it needs to be sold or something like that. Okay, so that's the thing. So what we are doing is in each and every orange size, we are taking the size and we are just uh, pushing it to errors and cells. So errors and cells is empty array. What we are pushing is we are pushing a tuple over here, and we are pushing the distance of the orange size and the size over here, right? And we are pushing the cell over here. So that's the thing. And okay, right. Uh-huh. Okay, okay. So I think I need to Uh, okay. I need to even change my notebook, I think. So in notebook also it's wrong, I think. Okay, that I'll just do. Okay. So I've put, okay, so let, oops, size, okay. Okay, I think I've messed up something. Okay, so I think I need to put some, okay, let's have a orange size of 5. So we need to, oh yeah, I just got it, yeah. So we have orange. Like let's say, like in future, we have a machine learning algorithm that picks an orange, it's whose diameter is 5 inches or something like that. So we need to calculate errors and cells for that. Okay, so that's what we're just doing. And yeah, Julia's fast. Just calculated, right? Of course, in almost any programming language, this will be fast. Okay, so we just have this things like okay, the error and the label over here. So all we need to do is sort, get the first k labels, that is the k nearest labels, and then vote for it. Okay, so that's what we need to do. So for that, like what we do is like okay. So for that we choose a k value of 20. So something, right? So we just choose a k value of 20. I don't think the k value should be 50 because there's only totally 50 samples. Okay, so and what we do is like nearest errors and cells is like okay, we just sort this errors and cells so that it'll be like from the least error to the most error, and we take 1 to k off. Okay, So that's the thing. So now itself you can see like okay, like it's almost everywhere edible fruit. Okay, so I think the edible fruit just won. Okay, so like at least for me there was a juice. Okay, so like okay, what was my orange size then? Okay, even for me it was fine. Okay, but yeah, like that's how it is. Like every time we are generating random data, right? So that's how it will be, right? So now we just take this nearest cells. Okay, so we don't want the sizes anymore. This is sorted. So we just want to take this nearest cells and just put it as array. We don't want the sizes. Now it's been sorted and we have taken the first 20. So we just want only the cells like edible fruit and all those stuff, right? So okay, so we just take this nearest cells. Now itself we can see like edible fruit as one, but the computer needs to do something to find it, right? And okay, the counted nearest is nothing but we are passing it to the counter. Remember, we did this function right over here. Where is counter? Okay, right over here. Okay, this will return what to say a dictionary containing the counts of each and every label. So I think we need to put it as a library. Maybe we might need it in future or something. Yeah, but let's see. So now it's only edible fruit. So definitely, if you pass to highest vote, it's definitely going to be edible fruit. So that's the thing. So okay, yeah, fine. So this is how a computer determines. So possibly you need to write a function like determine orange category or determine where orange should be sold and all those stuff. Put this code into it and all those stuff. Okay. But yeah, this is only understanding k nearest neighbor. So that's the thing. Possibly in the future, if we are doing something real world problems, yeah, like we might write a function like that, plug into a software and see it work and all those stuff. So that's the thing. Anyway, like I hope you enjoyed this video or not. Yeah, like the only thing what I can do is hope. Yeah. Anyway, like thanks for watching. Let's meet in next video.